Hello everyone, today we are talking about changing attributes. So we are going to be changing one attribute, either length, width, or height of a rectangular prism and seeing what happens to the volume and the surface area. Now we are talking specifically about changing these attributes through multiplication. So we can be multiplying them by numbers like 2, 3, or 4, or we can multiply them by fractions like 1/2, 1/3, 1/4. So the volume is going to change the exact same way as whatever side you are changing. So if I multiply the length times 2, the volume is going to be multiplied by 2. If I take the width and multiply by 1/2, the volume is going to also be multiplied by 1/2. So that volume changes the exact same way. The surface area, on the other hand, is going to change, but it's not going to change the exact same way. So if I'm multiplying by those bigger numbers, the 2, 3, and 4s, the surface area is going to get bigger, but not going to be multiplied by that 2, 3, or 4. Similarly, if I multiply by a fraction like 1/2 or 1/3, the surface area is going to get smaller, but it's not going to be that exact proportional relationship like we see with volume. Let's take a look at an example over here. So you can see we're starting with this rectangular prism. It's got 3 by 2 by 2. I'm going to take this width of 2 and we are going to double it. So now it's going to be 4. So if I take that 2 times 2, I get that width of 4. I'm keeping everything else the same. I've still got 3 as my length over here, and I've still got 2 as my height. So those two numbers are not changing. And when I multiply that one attribute by 2, the volume is also going to be multiplied by 2. So I go from 12 cubic units to 24 cubic units. Let's look at some more examples of this. So we're going to start off with this rectangular prism here. I've got our length of 7, our width of 5, and our height of 3. Now, when I plug in those formulas, remember that volume of a rectangular prism is length times width times height. I get 105 centimeters cubed. And when I plug in that long formula for surface area, I get 142 centimeters squared. So we're only changing one measurement at a time. So in this first case, we're going to take that length of 7 and we're going to triple it, which means that that 7 is going to turn into 21. So let's go back and plug in those same formulas, our length, width, and height, but now we've got 21 times 5 times 3. And when we do that, we get 315 centimeters cubed. So let's take that 315 and we're going to divide it by my original volume, that 105. And when I divide those two, I get 3. So that means that this volume was also multiplied by 3, just like that one side length. Let's do the same thing with surface area. My new surface area is 366. When I take that and I divide it by my original surface area of 142, this time I get about 2.6. So we can see that the surface area got bigger, right? We started at 142, we went to 366, so it still is getting larger, but it's not getting larger at that same proportion as the volume is. So the volume is 3 times the original volume, but the surface area is only 2.6 times the original surface area. All right, so now let's see what happens when we're multiplying by a fraction instead. So now, again, starting from scratch, we're only changing one thing at a time. We're going to take that height of 3 and we are going to multiply it by 1/2. So we're changing that 3 into 1.5. So let's calculate that volume with that new height. And we get 52.5 centimeters cubed. Now again, if I take that new volume and I divide it back by the original 105 that we had, this time I get 0.5, which is the same as 1/2. So that volume is half of the original volume, just like that height is half of the original height. Let's try again with our surface area and see what happens. All right, this time we get 106 centimeters squared. So when I divide that by the original surface area, that 142, this time I get about 0.75, which is about 3/4 of that original surface area. So we can see it got smaller, right? It's not as big as it was before, but it's not changing at the same rate as that one side length is. So again, our volume is always going to change the exact same way. Our surface area is going to get bigger or smaller, but not in that exact same proportion. Next up, we're going to look at some test-taking strategies. So let's take a look at some of those questions you might see. So our first one, we have which method would result in reducing the volume to half of the original? So we know that if we want half of the volume, we need to change one of those measurements through multiplication, multiplying by 1/2. So if we multiply each dimension by 1/2, that would mean changing all three. So that is not correct. We only want to change one at a time. We know we're not subtracting, right? That's not going to give us what we want for our answer. If we multiply each dimension by 2, then again, we're changing all three dimensions, which doesn't work. And also it's going to be bigger, right? Because we're multiplying by 2 instead of multiplying by 1/2. So our answer is D. We want to just take one of those. So they're saying the height and multiply it by 1/2 and keep the other dimensions the same. So we are always just changing one attribute and the volume will change the same way. All right, this next one, we have a rectangular prism has a volume of 100 cubic inches. If the width of the prism is changed from 12 to 3, what will the new volume be? So this one's tricky because we can't actually multiply and figure out the new volume. So what we need to do is see how that one side is changing. So we're changing from 12 to 3. So we know to go to 12 to 3, or from 12 to 3 with multiplication, we're really kind of dividing by 4. And so that means that we are multiplying by 1/4. So we have this 1/4 of the size. So we're going to do the exact same thing with that original volume. So if my original volume is 100, we know volume changes the same way. So I'm going to take 100 times 1/4, and 1/4 of 100 is 25. So our new volume is going to be 25 cubic inches. And our last problem for today, we have an original rectangular prism shown, and we are going to create a new prism by changing only one of the dimensions, and we want that new volume to be twice the original volume. So that means that we need to take one of those measurements and multiply it by 2. All right, so we are going to look at these one at a time, and we're going to first see which attribute they change, so our 3, our 4, or our 2, and we're going to see if they multiplied it by 2, that means that our answer is good. If they did not multiply it by 2, that means that that one is out. So let's take a look at this first one together. They are changing this 4 into a 2. So they did that by dividing by 2, and so we don't want to divide by 2. That means it would have half the volume, so this one is out. If we look at our next one, again, they're changing that 4, but this time they're changing it to 8. So this time they multiplied by 2, which means our volume will also be multiplied by 2. Next one over here on the right, this time they changed our 3 to 6. So 3 to 6, we're multiplying by 2. That would be twice the volume, so this one is correct. Our next one on the bottom left, they're changing our right-hand side, that 2 to 4, again, multiplying by 2. So that one is correct. And our last one, they changed our 2 to 1 this time. And so that time they were dividing by 2, so it would have half the volume. So that one is incorrect. And notice that they only changed one number at a time, which I stopped highlighting here. But we're really just focusing on that one number at a time. All right, so hopefully we're feeling more confident in what happens when we change attributes of rectangular prisms, and we can see what happens to the volume and what happens to the surface area. I hope you have a great day, and I will see you next time.